Hello and welcome to the chapter 3, Securing Platform Access Code in Action. In this particular chapter, we are actually going to start, first of all, by installing Keycloak. So let's actually get our instance started here first. So we basically started the Docker with the appropriate Keycloak credentials. Once that is there, I also want to point out that we are using this port 8180 as opposed to 8080 typically because 8080 is already being used by the kind clusters control plane port mapping that we did in chapter 2. After you do that, the next thing is a little bit tricky. You need to start storing your key clock credentials in Bitwarden. So this is sort of like a one-time setup. So we should go ahead and do that. So let's actually see if we can go ahead and make that happen. So we just did the command for that one. So let's see if it is actually going to go through. You can see that it started the process. Let's see if it is going to sync. It's excellent. So what you just see is that the key clock credentials are now from Bitwarden, right? I mean, so I think that is the idea here. Now let's actually get into the next step. In this step, what we are actually going to do is go ahead and first source the load secrets shell. So let's see where that file is. Oh, you're going to chapter 3 here, and here, let's see, load secrets. So this is how we would actually load the key clock credentials from Bitwarden Vault. And that's basically what we want to do. You don't have to use it, but since we have been trying to standardize on the Bitwarden, we will actually try and do it there. All right, so what we're actually going to do is going to just source this up first. And now this is authenticating with the Bitwarden, and it's starting to unlock the vault. And it's basically unvaulted. It's unlocked that vault. Then it's going to look at it and see where the admin password is, and how is it actually loading the various the three things in here. So you can also see immediately that there is a problem. You see that the key clock admin, key clock password, and key clock URL not found in Vault. So why would that be, right? This is tricky because, and that's the reason why I want to show this. So first thing you do there is go ahead and list your Bitwarden, key clock, and the session details. So now you can see that each of these variables, key clock admin, key clock password, and key clock URL are all loaded from the vault. So that is good. Now we can move on to the next step. So first thing you would do is before applying security controls, we need to baseline the cluster. So this audit sort of checks RBAC, network policies, port security standards, and maybe even secret encryption, giving it like a snapshot before. So how would this look? Let's take a quick look at the security audit. So you can look at the security audit script. This is how you audit the Kubernetes cluster for typical security misconfigurations. So to do that, what you just need to do is run the script. So you can see that it's auditing all the namespaces. Now you can actually start configuring the key clock realm. So key clock sort of provides that OIDC based SSO. So we create a dedicated realm with clients for Backstage, Argo CD, and all those, and maybe even for Grafana, so developers can use one login anywhere. And I think that is the whole purpose of using the key clock, as we discussed in the book. So let's actually set the realm. First, look at key clock realm config. Where would that be? Key clock realm config. We can see that here. So it sort of automates the creation of a key clock realm for platform SSO integration, creates realm, OAuth client roles, and user mappings. So you can see that. And now let's go ahead and run that. Um, Excellent. That did that. Now the next step would be we need to verify that whatever we ran, we just need to verify that. So we will run this with verify. So it's successfully authenticated with key clock, realm verified, found the roles and the clients. So it sort of completed everything there. Good. Now it is time for us to move on to the next step here, which is to apply the RBAC roles. So these manifests define who can do what. I mean, that's the whole purpose of these manifests, right? So platform admins can get cluster-wide access. Developers are scoped to their specific namespace and the sort of least privilege in practice. So we create the required namespaces first. The RBAC manifests reference service accounts in the platform engineering and the platform dash engineering and the platform namespaces. So let's give it a go and see if that works. So creation is pretty simple. Yeah, you can use the same commands given in the README file. Let's see if it is trying to create that. You can see that I had a previous run in which platform was there, so it obviously says that you can't create something that is already in place. So it gave me an error there, which is fine. Can ignore it. And it just went through the whole process. Now, once we have done that, next step is to test that RBAC permissions. We impersonate the CI/CD service account to verify it can deploy to its namespace, but it's blocked elsewhere. So this sort of confirms if the RBAC is working. So to do that, let's go ahead and run our kubectl command. See if that works. Yes, so it confirms it works. And the next one, what we're going to do is see if this one is deployed in production. It should be a no. Let's see what it's going to say. Yeah, it is good. It says that it's a no. Okay, so now it's time for us to deploy the cert manager and issue a certificate. So let's see how that works. So we will apply the cert manager config. So you can see the cert manager config here. You can actually look at the cert manager config and then go ahead and apply that. You can see it's going through each and every one of those things, creating that. You can actually start deploying the OPA gatekeeper policy. So gatekeeper, as we discussed, access and admission controller. So every resource passes through these policies first. So we require these resource limits and namespace labels. That's what we are going to apply. So let's see if that would work. Okay, so we created the Kubernetes require resource limits for gatekeeper. Let's try and do the next one. Constrain namespace labels. Okay, so this was already existing, so it didn't have to recreate it. Okay, so now we can demonstrate that policy enforcement. So the payoff is we submit a non-compliant pod, let's say missing resource limits, and the gatekeeper denies it. Then we fix that spec and then let it go through. I mean, that's the whole idea that what we are trying to do. So we can actually go ahead and do the kubectl apply and see if that pod is working or not. I think that's something for you to try out based on the exercise that you have. Now we can actually run the permission test and the final audit. So let's actually go ahead and run the test RBAC permissions. So we have your test RBAC permissions here. So it sort of validates RBAC configurations and restrict the access accordingly. So we can go ahead and try that. It ran all the tests and told you which test passed. And then finally, we actually do another security audit and says that everything has been audited and looks good. So that's pretty much it for the chapter 3 code in action. Thank you.